Certainly very happy to be here at GeeCON this year. In fact, I came to Krakow 3 days ago. I was actually here last month, and it was very nice and warm and sunny, but this time around, it's been raining all the time. So for the next 45 minutes, what I will do is talk about leveraging emerging technologies for competitive advantage in travel. I work in the travel industry, so I work for Sabre. I'm part of the Sabre Labs and Product Strategy organization. And as most of you do know, Sabre is a travel company. So we develop software solutions for airlines, hotels, rental car, and cruise line type companies. In addition to that, we also operate the world's largest marketplace, where we bring sellers and buyers into a common setting so they can transact business. So towards that end, when I start this presentation, I'm first going to start with providing you context. The context I'm going to start with is the travel industry. If you think about you in the audience today, most of you work in some industry or the other. It could be automotive, it could be telco, it could be finance, financial industry, could be insurance, and a whole host of other industries, could be retail. And every industry, when you go back to the workplace, what you will typically find is that you have your own challenges, right? The reason you go to work is because you have to be competitive. And the question is, you need to overcome the challenges with the latest technologies that you can actually use for competitive advantage. So I want to first provide context as to why this is important in my industry, which is travel. And I have been in the travel industry for a long time. I've been there for about 25 years. I started my career back at American Airlines, and then I transitioned to Sabre. And so we'll talk a little bit about the challenges in the airline industry, just to set the context. So one of the things you see is that there's been a growth in air traffic volumes for the last decade or so. And if you think about deregulation that happened about 30 years ago, the airline industry has gone through large number of transformations. And with those transformations, what happens is that business process changes, new value propositions evolve, and you need to determine how exactly, as an industry, as a company, you can remain relevant and competitive in the marketplace. So this is a capture from NATS. NATS is an air traffic control company. And this is over the skies of Europe. So typically on a given day, there are about 30,000 flights in the air over Europe. And the total distance traveled is about 25 million nautical miles, which is equivalent to about 102 round trips to the moon, or maybe almost 1,000 round trips around when you orbit the Earth, right? So traffic has been growing at an alarming rate. And this is basically a slide from IATA that basically confirms a point that I just mentioned. If I look at the last 12 years, the only year when we had negative growth was 2009, because 2008, you had the financial meltdown. So 2009 was the only year when you had negative growth. And the average growth has been around 6% a year, and last 2017 was the highest at about 8.5%. Now, one of the key things we also notice in the industry is that we have a lot of systems at Sabre to support travel. One of the most important systems we have is what we call as a shopping application. Shopping application is our largest application we have at Sabre. We have over 3,000 servers that basically support the shopping application. For those of you who are wondering what I mean by shopping, when you go to an OTA site and you basically say you want to go from point A to point B, there is a process by which itineraries are generated and displayed on a page. So that process is what we call as shopping. And for example, one of the things we have noticed is that the growth in shopping volumes has been very high. Last year, we did 170 billion shops in 2018. and it's growing at the rate of about 60 to 70% a year. So we are basically predicting a volume of 275 billion shops in 2019. Most of the development for our shopping solution is done right here in Krakow in our offices, where we have a large shopping team that works on various aspects to bring the solution together. It's one of our most mission-critical applications used by a very large number of OTAs, a large number of travel agencies, and a large number of airlines, right? So, one of the things to also keep in mind in the airline industry is that it's been very, very competitive. Just like in your industries, whether you work in retail or you work in telco, you'll notice very similar trends where there's a lot of competition. And competition is good. It brings out the best from an innovation perspective. So if you look at the last 12 years in the airline industry, the actual base fare that people pay has been going down at the rate of about 1% per year. This is not good. But at the same time, they've also been selling ancillaries, which is the base fare plus the add-on products that they sell. So that has been growing at the rate of 40% for the last 10 years. So last year, in 2018, the ancillary sales was $93 billion, which means that in 2019, it'll exceed 93 billion, which means that we need to think about how to solve that problem and how we can position and provide a solution for travel agents and customers so that they can promote the right bundle to the right customer at the right price at the right time. So we'll talk about some of the emerging technologies that we are leveraging in terms of how we solve this problem. Okay. Just to recap what I said earlier, so the complexity in travel is increasing at an alarming rate. In travel, it's no exception. Some of the topics I have listed on this page may not be very meaningful to many of you, like NDC. This is a new messaging standard that has been established by IATA, which is the International Air Transport Association, working with airlines to communicate to marketplaces like Sabre. So this has had big impacts in terms of the number of fares that are being filed, the volume of fares that need to be processed, and so on. So broadly speaking, there's a lot of complexity in air travel, and we need to grapple with it. It's no different than what you have to do in your industry. The important point is you need to do it with the right set of tools, the right set of software, and to build these applications to make sure that you have a competitive advantage. Now, just briefly talking just about Europe, Europe is no exception. If you look at Europe, we've had a large number of bankruptcies in Europe. Back in 2003, we had 180 airlines. And today we have, just last year, 14 airlines went out of business, which is not good. And low-cost carriers like EasyJet and Ryanair tend to take market share from the traditional network airlines. So my main mantra or message is that innovation is not a luxury. It's a sheer necessity in our business to be competitive. And the way you remain competitive is to deliver these solutions with people like you in the audience who are writing software. Whether you write that in C++ or Java, Python, or any other language, that is the way you stay competitive in the market. So let me just briefly talk about data. Now, data is probably the single most important asset that any airline would have. The reason why data is very important is because you want to be in a position to collect the data, be able to understand what the data is all about, understand the needs of consumers, and then be able to build applications so that we can solve specific problems in the travel domain. So from that perspective, this is very important. Now, in terms of the process itself, we actually follow a 3-tier model where we basically collect data that could be structured data or unstructured data, right? In today's world, we also have the big data environment where a lot of the data coming into our systems are not structured data, but unstructured data. Then you build the tools, the analytics and insights on top of it. And then finally, you build a product or a solution, and you can also visualize the results. So this is kind of what we mean by a three-tier structure. So many years ago, like 10, 15 years ago, when we used to build applications, we had a set of tools that we would use. But if you ask me as to what has happened in the last 5 years, the tools we have at our disposal have grown exponentially, and I will talk to it in a minute. And it's very important for every one of you in the audience here to get to be aware in terms of what these tools are and how you can actually use these tools so that you can build first-of-a-kind value propositions. When I say first-of-a-kind, what I mean is you want to be in a position to build industry-first applications in your industry, right? So that is kind of important. So just to recap the data, we have internal data and we also have external data. Most industries have the same thing. If you look at retail industry, for example, they have internal data. They also have external data like Nielsen, for example. So we have internal data and external data. The end result of all this is we have over 15 petabytes of data sitting in the Sabre system, right? That's a large amount of data. For example, I mentioned earlier the shopping system we have. The shopping system, for example, we do, as I told you, we did 170 billion shops in 2018. The peak transaction volume processing for that setup is about 20,000 transactions per second. And we also generate about 1.8 trillion itineraries, which are individual trips that are returned in a given month for a given across all shopping requests. So all this goes into our databases, and the shopping data alone coming into our systems, or raw data, is 300 terabytes a day. So you get an idea in terms of the magnitude of the data that is coming in. And we have over 15 petabytes of data in our systems. And we want to use that data to understand consumer behavior and how we can improve our relationship with consumers, interaction with consumers, to simplify the travel experience for the consumers. That's kind of the key intent, because we want to hide all the complexity that comes with the regulation and other complexities in the travel space. So one of the things that's also important to keep in mind is big data is a new normal. We've been investing in big data appliances for well over a decade. We started out small, and we have a large amount of data going into essentially this is a clustered environment. And if you think about big data, it came about when Google first published a paper on the Google File System, or GFS. And along with that, they also described a parallel processing method called MapReduce in terms of how you can access the data, and they were using it for their web search. That's kind of what they were doing. So these two components came together, and this is what led to the creation of Hadoop a few years ago. So Hadoop is a very important environment because it enables you to store structured data, unstructured data on cheap commodity hardware. And then you can, once you store it there, you can use MapReduce. You can run a MapReduce job on it to go back and access the data, understand the data, and then to go ahead and build applications. So this is a very important it's a very important component. The next thing I wanted to bring about is when you're talking about data, the question is what kind of tools can you use on top of the data so that you can build applications that make sense, that are competitive, and have unique value propositions. Make no mistake that today we live in an AI-enabled landscape. So artificial intelligence-enabled landscape. Artificial intelligence by itself is not new. You know, the concept of AI came about back in 1950 when Alan Turing wrote the landmark paper saying, "Can machines think?" And then it made some progress all the way through the 80s and 90s, but artificial intelligence didn't really take off in a big way until the last decade, right? And all of a sudden now, we have access to a lot more tools. There are so many startup companies that are building software applications. There are so many, plus we have access to AI toolkits from all the large cloud providers. So Amazon, AWS, Microsoft Azure, Google Cloud, these are all examples where it becomes easy for you as an individual to basically access these sophisticated tools and to build applications. The best part of it is that you don't need to be an advanced statistician to do it. You need to understand, you need to be able to select the right model, you need to know how to set up the model, you need to know how to feed the data, how the data is processed, and how to deploy the model. So that is where the challenge is. And the mathematics, in terms of these sophisticated models, in terms of how they work internally, you don't really need to know that in great detail. You just need to know in terms of what type of problems are solved by what type of tools, right? So that's kind of important. So artificial intelligence, again, is a very broad concept. It's machines carrying out tasks in a way that we consider to be smart. It's a very broad in scope. The one way to classify them, artificial intelligence, is to say we have process automation related work, cognitive insight, and cognitive engagement. That's one way to break it up. And you see that in some papers in the Harvard Business Review and so on. Another way of doing it is to say you have machine learning, you have natural language processing, and then you have deep learning, right? So these are the three major elements or components of artificial intelligence. Okay. I want to touch upon machine learning because within AI, at least at Sabre, we tend to focus, many of our applications we develop use components of machine learning. So this is a very interesting thing that I think every one of you in the audience should be aware of, and you should make an attempt to understand how these models actually work. The reason why it is important is because this is programming with a twist. You don't actually explicitly program the outcome, but you basically build a model and you train the data to use the model, and the model will then make a prediction, and it'll keep improving its prediction over time based on the new data that is coming into the environment. So essentially, it promotes a process of continuous improvement. If you think about the travel industry, this is very important. Why is it important? Because people's attitudes change. You know, people's attitudes 10 years ago versus 5 years ago versus today, they change all the time. So when you build applications, you want to make sure that you can adapt and make sure that the recommendations being produced are consistent with the needs of the consumer at a given point in time, right? Which is the current day. Okay. Recently, PwC did a survey, and they came back and said, just because of artificial intelligence, virtual reality, and machine learning, the global GDP is going to grow by 14% incrementally because of these three technologies. This has got the capability for changing the entire large ecosystems if that is the case. And the 14 points of GDP that I mentioned essentially translates into 15.7 trillion to the global economy in the next 12 years or 11 years. So this is something to keep in mind. The other reason why, as I mentioned earlier, having a self-learning method built into applications is important is also because consumer expectations are evolving. Even if I said to myself that in the travel industry we don't need to use some of the latest technologies like artificial intelligence, consumer expectations are evolving, and they're evolving not based on what they are doing at an OTA site or talking to a travel agent, but they're actually influenced by external forces. External. So what are these external forces? For example, you got mobile phones, right? So there's an expectation that you'll have 24/7 mobile access. Amazon has a recommendation engine. That recommendation engine that Amazon has is a machine learning model that basically gives you a set of recommendations in terms of what to buy. And that recommendation engine generates 35% of the total revenue for Amazon. There are also some simpler examples like Starbucks. They claim that they have 87,000 different drink combinations that can serve up in the time that you wait for a cup of coffee, right? And Netflix has a very sophisticated recommendation engine that takes your past history. It also takes data from across its entire universe of customers. They have 110 million customers, and each customer has about 3 different profiles. So if you multiply it out, you're looking at 300 million types of potential profiles that they have to deal with. And they basically have a recommendation engine that looks at your past history, looks at what other people are doing, and so they can recommend to you what movies they think that you want to see, right? So this is, again, a highly sophisticated version. They started out very simple with a much simpler model where they did everything by zip code or by location in terms of recommending movies. Today, they don't do that. Today, they take your data and they look at the data worldwide and say that people of this type, people who watch this movie also like these movies. And it may not be the entire set of action movies, for example. It's a subset. So they do micro-segmentation in terms of how they make the recommendation, right? So these are things that are fairly important. Let's talk briefly about programming languages. So I know this is a developer conference. So in the world of AI, there are six major programming languages that are in use. Some of them are historical, like Lisp and Prolog. They have been there for a long time. Lisp actually is the second oldest programming language after Fortran. And it was actually developed by John McCarthy. He was a man that actually coined the word artificial intelligence. He's from Dartmouth College. Prolog is more of a declarative programming language where you basically say what you want to do. You don't say how you want to do it. The compiler takes care of the how. These are older languages, and more recently, most of you should know that C++ and Java are used widely. Java, of course, is the most widely used programming language. And if you think about Java, most of the open source libraries are built on the Java JVM, right? For example, you have the Apache Hadoop. You have the Apache Spark. You have Apache Cassandra, Apache Kafka. And more recently, you also have natural language processing, which is the Apache NLP. And then we also have the Stanford Core NLP, which is used for natural language processing. And these are all written in Java. Just want you to know that. But I think what's happened over the last 5 years is that Python has seen a very large adoption rate, right? It has a very large adoption rate, especially in the world of machine learning and artificial intelligence applications, because the library of tools that you have access to with Python is probably greater than anything else you see on this slide. So Python is gaining in popularity, and Google, I think, is a big advocate of Python that you might have heard in the press from time to time. And finally, we also have the R programming language. So R also is open source, and this is, in some ways, an open source version of the SAS programming language, statistical analysis system. And this also has a large number of libraries. So for the last 5 years, the two languages that have seen the highest growth rate in terms of adoption and usage have been Python and R, right? Okay. As I mentioned earlier, we have a large number of data platforms that are, and data science platforms and machine learning tools that are available in the marketplace today. And then on top of that, we also have the large cloud providers like Amazon, Google, and Microsoft, who also give you access to a large number of these same tools. So, and this world is evolving very rapidly. What I mean by that is, if you go back and ask me how many new software companies popped up on platforms or data science platforms. There are so many new ideas, new concepts that are coming out on a very regular basis, almost to the point it is very hard to keep up. But I think it's important to keep up because it's important for us to do the right selection of the right software to build the right application when you want to build an application. So, and we are, as at Sabre, we also have a hybrid strategy for cloud. So we actually use a private cloud, and we also have a public cloud. So this is our basic structure. So we have two private cloud establishments, and then we also have the public cloud where we have a lot of applications running in AWS, Azure, and Oracle, okay? So, and when we have these things running on Google Cloud or AWS or Azure, we also have access to all the machine learning tools. So the data is already there. We can build the application, we can deploy it, and it's good. So one of the things that's important is, Sabre has been in the business for a long time. We have over about 12,000 people in the company, around 7,000 of them are in technology, and many of them are software developers. So one of the things we did last year is to raise awareness across the company about the importance of thinking about opportunities for embracing and adopting machine learning or artificial intelligence as part of the software development process. So towards that end, we launched what is known as the Artificial Intelligence Special Interest Group at Sabre. So as part of the Special Interest Group at Sabre, what we do is we do training. We trained a lot of people last year, close to 500 people, and we are training more people this year. In addition to that, we also have recommended toolkits for people to use, and we also serve, in Sabre Labs, we also serve as a focal point. If people have any questions in terms of how to use the tools, there are people on the team that I can actually help you do the right selection and also help you deploy the model if need be. And on the left, you see is a newsletter. So we also launched a newsletter that we publish once a quarter. The focus is on use cases, to talk about specific problems that we are solving and how we solve it. This is why I think this transformation is very important, not just for travel. This transformation is important for any industry, right? Because we live in an AI-enabled landscape. We want to make sure the rank-and-file developers in the organization have a basic understanding of artificial intelligence and machine learning. So when as long as they are aware, if they see an opportunity, they can bring it to the right people and ask them to go back and solve the problem. So that is kind of important. Okay. So what I want to do next is to switch gears and talk about some simple use cases in terms of why and the question you need to ask yourself in the audience is, if you were posed with a similar problem, how would you have solved it? Okay, so this is something interesting. I did not even know this problem existed. About a year ago, one of Sabre's customers came back and told us that when people are trying to check in at the airport to go on a flight, they take their passport to the check-in, then the machine-readable zone is not able to understand the passport. So some countries in the world are not ICAO compliant. ICAO, as you see here, is the Civil Aviation Organization. So what that really means is that when you put your passport in a kiosk, it cannot automatically read the information because we have no way of knowing what is the first name and what is the last name of that passenger. So if you go back home and look at your passports, if you see a double arrow next to your name, that means it is compliant with ICAO. If you have a single arrow next to your name, then it is not compliant, and the kiosks will not be able to read your passport. So we actually had to build a model to solve this. This is a difficult problem to solve. So what we ended up doing was we used a technique called supervised learning, which is we took about 500 names of people and had an expert go back and classify them. And then we ran what is known as recurrent neural nets It's a specialized technique for solving problems of this nature against a data set, and then we made predictions for about 100,000 names. And we found out that the accuracy of this application was around 85%, which actually is very good. So even though the kiosk cannot read it, in a situation like that, we can bypass a kiosk, run through the software, determine the last name and first name, and pass that information back so that reservation processing and check-in can continue. So this is also an interesting case of an example or a problem that could not have been solved with traditional techniques. You had to use a machine learning technique to solve this problem. Okay? The second one is robotic shopping. In our industry, I mentioned earlier that we do a lot of shopping. I mentioned that we have 170 billion shops in 2018. A large number of the shops are robotic, meaning that we think about 23% of the shops are robotic. And we also have a lot of customers who need our data, the request data, the query data, and the response data that are actually sent to them. And they want us to flag the request and tell them if it's a robotic shop or not a robotic shop. So to solve this problem, we actually ended up using a pattern recognition model to basically automatically detect a robotic shop from a non-robotic shop. The process may not be 100% accurate, but we are quite accurate in terms of predicting which shops are robotic, which ones are not, by doing pattern recognition. And pattern recognition is an AI technique. The third one, this is fairly important, is what we call as, in today's world, what is becoming very important in travel is the concept of personas. Persona is a segment of the population that we identify, and then personalization is basically saying, from that persona, we want to be in a position to do it for a segment of one, which is being able to give you a specific answer to solve this problem. So this solution to this problem, again, as I mentioned earlier, I spoke about the fact you want to sell the air component and also the ancillaries. So this is a solution to that problem. And here again, we used a combination of unsupervised learning for segmentation, and we used a machine learning technique for the recommendation engine to basically solve this problem. This may be something that's closer to what many of you may have seen. This is what we call as an intelligent virtual assistant. This is a digital concierge, just like a chatbot. Now, chatbots, as you know, are gaining in popularity for the last few years. And the reason it's important in travel is because a lot of the basic tasks, you don't want to have a person at a call center answer questions to a customer. They should be able to get the information directly from a chatbot. So we have built multiple chatbots at Sabre. We have chatbots for people in the crew area, like for pilots and flight attendants. As most of you know, all pilots cannot take vacation at the same time. Then you cannot fly. So airlines will spread the vacation schedules out. So once you get your vacation schedule, if you don't like the dates, you can do the trading with some other pilot to get what you want. And that is done using a chatbot. More recently, we built this for travel so that once you have a reservation made, you can go to the tool, you can go check your reservation, you can check the weather, you can change the seat, you can pay for a meal. All the basic tasks can be done with the chatbot. And chatbots are important because it's also a cost containment tool by not requiring a large number of people at call centers to answer these basic questions. One other area that's very important for us is, and I'm sure it's important for every one of you in the audience, because every one of you deals with contracts. When you work in any company, it doesn't matter if it's insurance or airline or travel agency, you always deal with contracts. So we have to deal with contracts between agencies and airlines, as an example, where they're given incentives when they make a booking. There are different types of incentives, and that's kind of what this slide is showing you. So what we want to do in a situation like that is we actually use natural language processing. So natural language processing is actually used to actually take the raw text data and convert that into a data model so the right terms and conditions are stored in a standard relational data model. And then we go solve that problem once this data is stored there. So these are some typical examples that I'm using. And for those of you who may have seen some of the newsletters, some of these use cases are actually described in them as well. So a big question that comes up is, what is next, right? So I'm going to end the talk by talking about the Gartner hype cycle. Gartner research, most of you know who Gartner research is. So one of the things that they talk about is in the context of emerging technologies. Typically what they say is that when you have a new idea, a new concept, typically what happens is there's some kind of a technology trigger, an innovation trigger. A lot of people get interested. And then you have a lot of expectations. It's all hyped. There's a lot of expectations saying it's going to solve world hunger. And then what happens is over time, people realize it doesn't happen because the return on investment is simply not there. So it goes down. And finally, what happens is over time, in some cases, you break out of that mold, that emerging technology, and you have a slope of enlightenment. And then finally, you have productivity, a plateau of productivity, meaning it's a successful emerging technology, right? Now, we have this concept I mentioned earlier of NDC, so we believe that it's now on the upward slope, though for a long time it was on the left-hand side. So this is kind of how Gartner classifies all the emerging technologies for 2018, right? Interestingly enough, when you look at this, most of these technologies are not anywhere close to the plateau of productivity, right? And they basically claim that they are maybe 2 to 5 years away, if they ever get there. So we at Sabre are always looking out for these emerging technologies, emerging trends, and basically placing bets and asking ourselves which ones we think will succeed, which ones we think will not, and for the ones we think will succeed, we will go out and define a use case, build an application, test that with customers, and test the waters and see what we want to do with it, right? So in this context, this again is a Gartner, what Gartner claims is, one is democratized AI. This is kind of important, I think. As I mentioned earlier, 10 years ago, most of you, including me, 15 years ago, did not have access to these tools that I walked you through. Today, you have access to these tools. It does not take more than a couple of days to get access to these tools and to start learning about them, right? So things like conversational interfaces, digital assistants, smart robots, these are all examples, but it's entirely up to us to learn the space fairly quickly. And I'd urge every one of you to at least attempt to do that in your spare time. If nothing else, it'll be rewarding from a mental perspective because you learn something new and you might be able to adopt it in the marketplace in your work environment. Maybe not today, maybe tomorrow. The second one is digitized ecosystems. There are some ecosystems like blockchain. Now, blockchain is an interesting concept. It's an extremely hyped technology when it came out. But if you think about blockchain technology by itself, it's a fairly simple concept. You have the concept of a ledger. You have the concept of a cryptocurrency. And you also have smart contracts where you have to execute. So we have actually built blockchain applications over the last few years and been successful at them. And we are experimenting with different use cases for blockchain technology, mostly in the context of fraud protection, and payments, right? For settlement is kind of where we focus our attention on. So I think there's value here, and I think it's going to come to fruition in the not too distant future. Do-it-yourself biohacking. This, I think, is a little far-fetched. Many of the concepts of biohacking are not ready for prime time. This is basically, example is using natural language processing to read medical documents, and then to propose treatment for cancer patients, as an example. I think we are very far away from being able to do that successfully. But there are some other near-term areas where I think it actually works. It's areas like virtual reality and augmented reality. So those are examples where I think this actually does work. The next one that's rather important to keep in mind also is transparently immersive experiences. We live in a connected world today. So what I mean by that is data can basically integrate with your laptops, with servers, with platforms, and the whole intent is that in this kind of environment, you can have a totally immersive experience. For example, there's some airports in the world, like the one in Edinburgh, in Edinburgh, in Scotland, where basically they have sensors at the airport, so they can monitor the queues and basically redirect people to the right locations to minimize wait times. Via the same technology, they can also determine variable manning, when they need to add more people at a certain station and when they don't. So this is actually happening today in a big way. You've also heard of iBeacons technology that's being deployed at a large number of sports venues and so on. So all that is only going to help this process over time in terms of optimizing the efficiency of workspaces out there. And the last one is ubiquitous infrastructure. Infrastructure is rather important. 5G networks, as most of you know, is around today. It's already been deployed at some locations, and it will see adoption over the next few years. For example, examples like augmented reality, virtual reality, and even mobile applications like a chatbot when you want to do inspirational shopping. When I say inspirational shopping, what I'm saying is you're basically asking a question. I want to go to the beach. I have 5,000 zloty with me. Where can I go with my wife, right? So that is what I mean by inspirational shopping. So this kind of data, the packets are much larger in size. So the 5G networks with the increased bandwidth will actually help that process. The second example I have is quantum computing. We've been working with quantum computers for the last couple of years to see how we can use it to solve some of the problems we have. We solve some of the world's largest problems for airlines, and some of those applications take a long time to run. The question is, if I use quantum computers, can I get them to run much faster? And the truth is, after the experiments we ran, the conclusion is quantum computers are not ready for prime time for optimization modeling, because we have to convert everything into what we call as a Kubo format, which is a quadratic unconstrained binary optimization format, and that is where it fails. But I think in the future, what you're going to see is that quantum computers will be able to solve very specialized problems. I don't think you'll ever see a general purpose quantum computer. I doubt that. But I think you will see specific classes of problems being solved with quantum computers. And the other area where this is very helpful is for artificial intelligence and machine learning, because we think about neural networks and deep learning techniques. These are all very CPU intensive. So when you want to solve these problems and you're using, say, Microsoft Azure, for example, you may actually want to use a GPU as opposed to a CPU because the processing power you need is much greater. So I think quantum computers could actually go a long way in the future to support solving deep learning models at a faster pace than what you see today. So thank you. So this was my last slide. Are there any questions or from the audience? No? Yes, there are. There are, okay. Yes, sir. Yeah, you actually raised a very good question. The statement in that slide is incorrect. The question really was, could you please expand on how Python is faster than C++? Um, that is not true. What I meant to say when I put that slide together, Python is faster than C++ for product development, right? From a time to market perspective, because it's a higher level scripting language, it is much, much faster to write Python code than writing C++ code. That's really what I meant to say. It's faster not from a software execution perspective, but mostly from a um, time to market perspective when you build the product. Is the other one? What's the second question? Saber's AI training available for people outside the company? At this point in time, the answer is no, but let me tell you what you can do, right? There's a lot of training available online, and it is free, right? There's a lot of training available online. So when we do the training classes, the only reason we do the training classes is because the training we do is not generic training. We talk about the tools, but then we give examples like what I gave you here about how it ties back to the travel ecosystem. So I thought that was important for people to understand why it can work for them, right? So it is not abstract. But there are lots and lots of training classes offered by Microsoft, AWS, and others, and Google, for example. There are lots and lots of presentations. There's also LinkedIn Learning. I forgot to mention that. LinkedIn has got a lot of training tools also that you can actually have access to, right? So I think it got locked up again. Yeah. And we are also advocating LinkedIn internally at Sabre. I want you to know. The only problem with online training on your own is that you need to be motivated to complete it. When we have a classroom setting and people come in, they have no choice. They have to sit and listen, and they have to complete the course. So what is the most recent technology that Sabre is betting for currently? That's a good question. So as most of you know, our business model is we are focused on intelligent retailing, distribution, and fulfillment, right? So let me talk about intelligent retailing. So we are focused heavily on building recommendation engines using machine learning for our airline partners and for our agency partners, like the slide I showed you earlier, right? So that is a big bet that we are placing. On the fulfillment side, what we are doing on the fulfillment side, we are focused on payment. And I think there are opportunities where blockchain can actually be very useful in the years ahead. Blockchain, you need to keep in mind, it is not good for high transaction volume processing. Even IBM's Hyperledger, when they talk about it, they have a disclaimer saying the max TPS, transactions per second, is 3,800. But in our case, for payments, we think this is an ideal solution. For loyalty, it can also work pretty well, and also for fraud protection. So blockchain, we are actually experimenting with multiple use cases. So let me explain what these use cases are. One is when you're flying out of Krakow, you may fly on LOT from here to Frankfurt, and from Frankfurt you may fly on Lufthansa to the US. So there are two airlines involved, and there's one ticket, and the ticket may cost $1,000. There's a process by which you determine which airline gets how much, right? So maybe LOT gets $100, and Lufthansa gets $900. Today, that process of settlement is legacy. It is done through BSP, bank settlement plans. And it takes 3 months to settle that transaction before LOT will see the $100. It takes them 3 months after the last segment is flown before they get the money. In the blockchain world, we're experimenting with it. The settlement can happen in 1 day after the last segment is flown. So the moment the person lands in New York or completes a trip, then we can actually do the settlement within 24 hours. So that is the power of blockchain. We're also looking at blockchain for a whole range of other applications. So that's the other area that we think is important that we're also looking into. The other area from a technology perspective we're also focused on is we are also heavily invested in the cloud infrastructure in terms of moving all of our products to the cloud. And we are also using OpenShift and containers to build our applications that gives us maximum scalability. Right. Any other questions?
Yeah, 3 of them.
Oh.
It's a robotic shop.
Oh, what is a robotic shop? A robotic shop is basically a robot that goes to a front end like an Expedia, right? And it submits queries, and the responses come back. They scrape the screen, and they store that information on a database. So that is what I mean by a robotic shop. It's not a person making the call, making the request. It's basically a robot that is submitting the request, getting the response, scraping the page, getting the content, storing it in a database. So that's what I mean by a robotic shop. The next question is, as a travel tech company with a massive leverage, what actions does Sabre take to fight the pace of climate change? It's kind of interesting. I mean, that's a tough question to answer. It's a very tough question to answer, but I do want to say that I think about 9 years ago, we had a person on, we have a person at Sabre, his name is Peter Birdie. He actually worked with University of Oxford on CO2 emissions, and we had made a whole series of recommendations to airlines as well as to aircraft providers in terms of what the study is and how aircraft manufacturers can work on reducing CO2 emissions, and also how airlines can actually help the process. So this was a joint study that was done with Oxford University. I think it was about 9 years ago. It's been a while.
And the last one is, can you see the slide with the hype again?
Can you see the slide? It's phases. Oh, sure. You want to see this? The question was, can I see the slide with the phases of the hype? So this is a generic slide. Okay. Can I go to the next slide? Is that what you wanted me to do? So this is just keep this in mind. And then this was the emerging technology slide, right? And one thing to keep in mind about blockchain, when we build our blockchain applications, we did not use IBM's Hyperledger or any other third-party infrastructure for blockchain, because we just wanted to fully understand how blockchain works. As a development organization, we really wanted to understand exactly how it worked. For a production system, we may still end up using a third-party infrastructure, but we wanted to build it out internally. And we came to the conclusion very quickly that a lot of the blockchain technology is actually not new technology. It's older technology. It actually uses linked lists and a hash to the next block as an example, right? So coding up the blockchain, writing the code for the blockchain, the infrastructure to build an application on top of it, we could do all that in about 3 months, right? We could do that in 3 months with just one developer working on it. Just want you to know. So a lot of people think, oh, blockchain is complicated. It really isn't when you go back and look under the covers, okay? And also on the cryptocurrency, you don't have to use a crypto that is volatile. There are a lot of cryptos out there that is tied to the US dollar, for example. So that'll be totally stable, all right? It also doesn't mean that we are looking into every one of these, but this is more of a Gartner slide. We pick and choose what we think is applicable for travel. Okay? So thank you.